Hi all, let's see the next topic of Unit 3, floating point representation. So in today's lecture, we are going to discuss about how to represent a floating point number and how do you normalize a floating point number using normalization technique. So in the previous class, we have discussed about a fixed point representation, which is used to represent signed numbers using different forms of representation, and we know that in case of a fixed point representation the position of a decimal digit is fixed, and uh, and coming to the disadvantage of floating fixed point representation, the main disadvantage is you cannot represent larger numbers in terms of a fixed point representation. So when you want to represent a very bigger number, then we deal with the floating point. We can represent a number by using a floating point representation. So the reason why for using the floating point representation is the range of possible values is much greater when you compare it with a fixed point representation. So you can represent a very small number or a very bigger number, which can be done by means of a floating point representation. So, coming to a representation of a floating point number, it mainly contains two parts. The first part is called as a signed fixed point number, which we call it as a mantissa. And the second part represents the position of the binary point, which we call it as an exponent. So, this mantissa, it can be either fractional, fraction part, or an integer part. So, if you look at this particular example, plus 6132.789. This number, this real number, can be represented in the floating point representation as 0.6132789 into 10 to the power of 4. So this is a decimal number we are representing in the form of 10 power. So since we are moving a decimal point towards the left, we are giving the exponent number of digits it moved 1 2 3 4. So you are representing as 10 to the power of 4. So here our mantissa in this particular expression is 6123789. The entire number becomes the mantissa, and exponent is 4 plus 4. So this is how a decimal number can be represented in a floating point representation. So if you see the representation of a floating point number, it can be represented in the form of m into r to the power of e, where m is said to be called as your mantissa and r is nothing but the base, or we also call it as a radix, and e is nothing but your exponent. So if you take a binary number, how do you represent this binary number in a floating point representation? Say I have a binary number 1 plus 1001.11. So I want to represent this binary number in a floating point format. So you can represent it as 0.1001110 to the base 2, which is because this is a decimal binary number, it has a base of 2 into 2 to the power of 4. So 2 is the base for a binary number. So it is represented into 2 to the power. So since I am moving this decimal digit towards the left hand side, I need to increase my exponent as plus 4. Four binary digits are more, so it has to be written as plus 4. So here the mantissa part is 1001110 is the mantissa. So along with the integer part, so here I have 0. So 01001110 is the mantissa, and exponent will be plus 4. Plus 4 equivalent representation is 00010 so I am representing in the form of a 6 digit, because they asked here in a 8-bit fraction and 6-bit exponent part. So I am representing it in that particular format. So now this is in the form of mantissa into base to the power of exponent. So this is how we represent a decimal number and a binary number in a floating point representation. So next comes the main important concept in a floating point representation of a numbers is the normalization technique. So normalization technique is mainly applicable in floating point number systems. It is a process for standardizing these floating point numbers into a consistent format. And Why do we need to standardize into a particular format is for ensuring the uniformity. And whenever your number is represented in a standard form, then it is easy to do arithmetic operations on those particular floating point numbers, as well as for accuracy of your information, uniformity, so that all the numbers stored in the system are in a uniform format. So for all these reasons, we need to normalize a floating point number. So for example, if you take a number 9257, you can there are different ways of representing this number in a floating point representation. So you can represent this number in the form of 9257 into 10 to the power of 0, or you can put a decimal digit here and represent it as 925.7 into 10 to the power of 1, because you are putting the decimal digit here. You are giving a power as 1. So if you move the digit towards your left, you can write it as 92.57 into 10 to the power of 2, or 9.257 into 10 to the power of 3. There are different ways of representing a floating point representation. But which is a standard form or a normalized form is if there is a single non-zero digit before the radix point, we can represent that particular floating point number as a normalized form or a standardized form. So between all these different methods of representing the number, this particular last one is said to be in a normalized form, because there is only one single non-zero digit before the radix or a decimal point. So whenever your MSB bit before the decimal contains only a single digit, which is a non-zero, then that particular format is said to be the standardized or a normalized way of representing your floating point number. So, for example, if you take this number 1234.567, you can represent it as 1.234567 into 10 to the power of 3, because you are moving this decimal towards your left by 3 digits. So, the power will be incremented by 3. So, it becomes 10 to the power of 3. So, by moving the decimal point, so only one digit appears before the decimal. So the exponent expresses the number of positions the decimal digit was moved either to the left. Sometimes there is a possibility that you need to move the decimal towards your right. In that case, your exponent will be decremented depending upon the number of digits that you move. When you are moving towards the left, your exponent has to be incremented depending upon the digits you move. So in this example, we are moving the decimal digits towards the left. So the power is incremented, exponent is incremented. So it becomes 10 to the power of 3. So this is a normalized form of representing a decimal in a floating point representation. So suppose you have a decimal real number of plus 12.510. You have to represent this number as a floating point binary number. First, you need to convert this number into a binary form. So for binary form 12, it is represented as 1100.510. You know how to convert an integer part separately and fractional part separately into a binary form. So 0.5, you can convert it, the binary representation is 0.1. So totally the binary representation of 12.510. So since I am giving a plus here, my sign bit is 0. So 0 1100.1 into 2 to the power of 0, where the most significant bit is said to be called as your sign bit. It represents the sign of your number. So since I am having a sign of plus, I am representing it by 0. So you can represent this number as 0110.01. I am shifting this decimal towards the left and increasing the exponent by 1, 2 to the power of 1. I can also represent it as 011.001 into 2 to the power of 2. Or I can also represent it as 01.1001 into 2 to the power of 3, or 0.11001 into 2 to the power of 2, or 2 to the power of 4. So all these are different methods of representing the particular number into a floating point binary form, but the normalized form is the last one. I'll tell you why this is the last one. So first let us see how to normalize a binary floating point number. To normalize a floating point binary number, you need to first determine whether the number is a positive number or negative number by checking the most significant bit of the mantissa part. So which is the mantissa? This entire thing is nothing but your mantissa. So by looking at the most significant bit of your mantissa, you can identify whether the particular number is a binary number, positive number or a negative number. If the most significant bit is, as I told you, this is a sign bit. If it is 0, it means the particular number is a positive number. If this bit is 1, it indicates the particular number is a negative number. So depending upon the checking the number, whether it is a positive or negative, there are different methods in normalizing that number. If it is a positive number, there is one method of normalizing the number. If it is a negative number, there is another method of normalizing. Let's see. So if the number is a negative number, so how do you identify the number is negative number? By looking at the mantissa. If the most significant bit of the mantissa is a 1, it means the number is a negative number. So in that case, you need to move through the mantissa from left to right until you find the first bit whose value is 0. So the binary point will be positioned immediately in front of this bit. So a normalized negative number, if you want to make the negative number in a normalized form, it should be in the representation of 1.0. It should start with 1.0 something into 10 to the power of. If it is in that form, we say that the particular negative number is in a normalized form. So let us take an example. Say for example, I have a floating point number which is 100.11 into 2 to the power of 1. So I have to make this number. So this is not in a proper representation. I have to make it in, because I have to have only one digit before the decimal. So this is having 3 digits. So I have to make it into a normalized form. Before that, I have to check whether this particular number is a positive or negative. By looking at the most significant bit, I understand that this particular number is a negative number. So in order to make it as in a normalized form, you have to represent a normalized negative number in the form of 1.0. So I have to move my decimal digit towards the left and place it here so that it is in the representation of 1.0 into 2 to the power. So I'll make it as 1.0011 into, since I'm moving it towards the left, by 2 digits, I'm increasing the exponent by 2. So 1 plus 2, it becomes 2 to the power of 3. So this is the normalized form of this particular number, where this number is not in a normalized form. So this is a negative number which is in a 1.0011 into 2 to the power of 3 is a negative binary number which is in a normalized form. Similarly, so if the number is positive, so when your number is a positive, which means the most significant bit of your binary number is 0, then you need to move the mantissa from left to right until you find the first bit whose value is 1. So if you look at a normalized positive number, it will always start with 0.1. Whereas the normalized negative number, it starts with 1. It should be in the form of 1.0. Positive number should be in the form of 0.1. Say for example, I have a number 0.01101. Is it in a normalized form? No, because it is not in the form of 0.1. It is in the form of 0.0. So I have to convert it in the form of 0.1. So if I have to convert it, I have to move this point towards the right and keep it here. So for that, I have to adjust my mantissa. So now my mantissa becomes 0.1101. And since I am moving it towards the right, I have to subtract my exponent by 1. How many digits I am moving? 1 digit. So I have to subtract my exponent 4 minus 1, which becomes 2 to the power of 3. So now it is in the form of 0.1. So this number, this positive binary number, is now in a standardized or normalized form. So you know, before performing any type of arithmetic operations on a floating point binary numbers, you have to first check whether the number is in a normalized form. If it is not in a normalized form, you have to adjust your mantissa and exponent parts in such a way that the number will be converted into a normalized form. Then only you can perform any type of arithmetic operations on the particular floating point numbers. So adjusting the exponents. If you move the binary point in the mantissa, you must adjust the exponent so that the value of the number remains the same. So every time you move the binary point one place to the right, you must reduce the value of exponent by 1. Whenever you move the binary point one place to the left, you must increase the value of exponent by 1. So if you look at these examples, when you are in the case of a positive number, you are moving your point towards your right and making the exponent, you are decrementing the exponent. And whenever your number is negative, you are moving it towards the left and then incrementing the exponent. So this is how you normalize a floating point numbers. So here there are two examples. The positive floating point number 0.00011 into to the power 5. So it should be, the positive number should be of the form of 0.1, but it is in the form of 0.0. So you have to normalize it. So in order to make 0.0, this point has to be, decimal point has to be shifted to here. So it becomes 0.11 into, since you are moving it towards your right, you have to decrement your exponent. How many digits you are moving? You are moving it 3 digits. So you have to decrement your exponent by 3. So it becomes 2 to the power of 3. 2 to the power of 2. 5 minus 3, it becomes 2 to the power of 2. So similarly, I have one more example. The positive floating point number 010.01 into 2 to the power of minus 3. So this is also a positive number because the most significant bit is 0, and this number is also is not in a normalized form since it starts with 0.0. So you have to normalize this floating point number in such a way that it starts with 0.1. So in this case, I move my decimal point towards the left and I make it as 0.1001. So when I am moving it towards the left, I have to increment my exponent. Based on the number, 2 digits I am moving. So I have to increment my exponent by minus 2. So into 2 to the power of minus 3, minus 2, it becomes 2 to the power of minus 5. So this is the normalized representation of this binary floating point number. So this is about a floating point representation and concept of normalization in a floating point representation. Thank you.